Thanks, Gerard, for letting me know.
Okay.
Okay, so I have started recording. This is Unit 1 for Summer 2020. And our first session is going to start at 8.1. So the first thing we're going to talk about is variables, algebraic expressions, and functions. So I've written down some notes here, and a lot of this may be things that you already know, but just in case my language is different from another instructor's language, just let me know. Variables are when we use a letter or symbol to represent some unknown number. So an example would be if I have x plus 2 equals 5, and we know that we have to subtract a 2 from both sides, and then we have x equals 3. So in this problem, our x is going to have the value of 3. If I have a problem that is x plus 4 equals 10, and I subtract the 4, then in this equation, x is going to have a value of 6. So this is what I meant by this statement. X in one problem could hold a value of 2, and in another problem have a value of 25. Here we showed where it had a value of 3, and then in this problem it had a value of 6. Now, this is very important to note. Please make sure when you're writing your variables or your symbols that you're always using something that does not represent some kind of letter. So my x, I'm always trying to put a little curl to it just so it doesn't look like a multiplication x. I have actually started drawing stars to function as my multiplication symbol when I'm writing things out on the board. And when you're doing this for elementary school, if you notice, and I'm sorry, those who've had me before know that I'll refer things back to when I taught. I always, if you start using symbols right away and making them represent something and kind of making a little key, that way when they go home, their parents will know. Or I would send out a newsletter and just say, okay, this symbol and their math and your students' math work is going to represent multiplication if they don't have an X. We know that we can always use the dot later on, but sometimes students get really sloppy and they would have 2 times 6, and that looks like 2 6/10. So make sure that when students are writing things that everything is presentable. I rarely use a T when I'm doing, because when I'm writing things really fast, I may not put that curl on the T, and so it ends up looking like a plus. And especially when I'm reading problems and reading work, if you're doing 4T plus 3, I can recognize that as 4T plus 3, but if we do 4T times 8 or something, then it's like, okay, something looks really weird. So if I didn't know that that was an expression that I was looking for, then I would think you'd had written something completely wrong. So make sure when we're doing letters and symbols that you make sure they're not looking like something that we don't want them to look like. There's also another definition that you need to know, and that is a constant. And these are called to have fixed values. So a 4 is going to equal 4 no matter how many different ways we do 4. So I have 4 stars, I have 4 dots, and also the symbol pi. That's a fixed value because we always use 3.14 and we never really write out the rest of that, but we know that pi, this symbol, is pi, and I'm not going to use that as saying, okay, well, 3 pi plus 4 is going to equal 26 and solve for pi. We can't do this because pi already has this constant value. So this symbol cannot be used as a variable. It can only be used as this constant. If anybody's taken any higher level math, you know you've got the symbol E, and that is also another constant variable. So there's certain things that we can have that we just cannot do as far as, you know, making sure we don't using those symbols. Now, when we're talking about expressions, if I have 3x plus 2, this is an expression because it does not have an equal sign. So if I'm working out a problem and I say find the expression, then my answer is going to be this. So when you have an expression, you're never going to have So when you have an expression, you'll never have a value for your variable. It will always be in this expression. Now, equations, if I had 3x plus 2 equals 25, and this is not going to come out even, I would subtract the 2 from both sides. 3x is going to equal 23. I would divide the 3 from both sides. And now x is going to equal 23 thirds. In an equation, we do have a value for our variable. So when we do certain things, if I ask you for what's the equation for a circle, for the circumference, then this is going to equal 2 pi r. So the circumference, which is c, equals 2 pi r. Now the area for a circle is going to be pi r squared. Where we have to know something here. We either have to know what the area is or we have to know what our radius is. Because like I said before, we already know what our value for pi is. So when we're working with different equations, sometimes we're going to be given two different variables, but when we actually work out the problem, we have to know what at least one of those variables values is going to be. So any formulas. Now, when you get on to, if you look on page 381 in your textbook, and when you get on, this is on the e-text, you can actually just go in when it comes up and it'll have e-text. It'll give you commonly used formulas, and those are for area of a circle, rectangle, circumference, triangular figures, different things like that. So we can actually find, you can see that some of the things given are actually going to be given to us, and some of the things we're going to have to actually find. So any questions about variables and expressions? So I'm going to read a problem, and I'll read it a couple of times and then we'll write it out. And this problem is actually, it's an example on page 381 in the book. And it says, the length of a rectangular is twice the width. Hang on, let's see if I can put it here. So we're looking at this one. The length of a rectangle is twice its width W, and the area of the rectangle is 15 square feet. What is the width of the rectangle? So the length of a rectangle is twice its width W, and the area of a rectangle is 18 square feet. Now, if you look right above there, you'll see that the area of a rectangle is length times width. So the first thing I would do is, I'm going to start on this page since you can read through that, sorry. Page 381. It says the length of the rectangle is twice its width. Draw a picture. We have a rectangle. It doesn't matter if it's what it's supposed to be. But we know that this is the length and this is the width. And it says the length of the rectangle is twice its width. So that means the length is going to equal 2W. Guys, I'm going to have to put you on pause or something because I've got somebody in my yard and my dogs are going crazy. So I'm just going to let you listen to my other dog bark from the inside. I'll be back in just a second. Okay, people. Is everybody still with me? So from this problem, we know that the length is twice the width of the rectangle, and then it also tells us that the area equals 18 square feet. So the length equals twice the width, and the area is 18 square feet. So all we're going to do is, we know that the area of this rectangle is length times width. Notice I put a little curl on my L. And that when we fill in, we know that L is going to be 2W times this W for the width, and that is all equaling 18 square feet. So multiply our right side together, we get 2W squared equals 18 feet squared. We divide by 2, we get 9 feet squared equals W squared. And this has worked out really nice, because now I know that I can take the square root of W squared. The square root of W squared is going to be W. The square root of 9 is going to be 3. And the square root of feet squared is going to be feet. So W equals 3 feet. So if we found 3 feet here, and we know that L is 2 times twice width, then we know that 2 times 3 is going to equal our L. So L is going to equal 6 feet. W equals 3 feet, L equals 6 feet. So even though we figured this out, we still need to go back, and I would go back and check. We know that the area is equal to 18 square feet. We know that we are going to multiply 6 feet times our 3 feet. 6 times 3 is 18. Feet times feet is going to be feet squared. So we have 18 squared feet equals 18 squared feet. And so that checks, and we've done our problem correctly. Always make sure that I always draw a picture when I'm given something like this, just to make sure I know where I'm at and what I'm doing, and make sure that nothing's going to get in the way of that. Now I'm going to show you the next problem down, and the next problem down says the associative law of addition is the set of integers states that a plus parentheses b plus c is equal to a plus b parentheses plus c. For all the integers a, b, and c. So what can we say about those variables? I will state this here. It says that a plus b plus c is equal to a plus b plus c. Now what can I do to prove this? I can actually give values for a, b, and c. So I can say that a is going to equal 2, b is going to equal 5, and c is going to equal, let's say, 4. So now let's put these into this equation we have here. We've got 2 plus 5 plus 4 is going to equal to 2 plus 5 in parentheses plus 4. Now as you're looking at this, these are just numbers I made up. These did not come from any certain place, so in case you're wondering. So when I'm working my problem, I know I do parentheses first. So 2 plus 9 is equal to 7 plus 4. 2 plus 9 is 11. and that equals to 7 plus 4, which is also 11. So you just proved the fact that our associative law of addition, which is our grouping, can be worked out and solved and proven. So any questions thus far? Okay. So when we're talking about, we mentioned algebraic expressions. When we're talking about algebraic expression, if we have the example, the cost of every item in a store is increased by 15 cents. What is the cost of an item So if every item in a store is increased by 15 cents, what is the cost of an item that used to cost C dollars? So in this one, this is an expression, so we're not going to have C equals or X equals or whatever. So this is going to be C plus 0.15. So C plus our 15 cents. And that's going to equal so many dollars. So our expression, C plus 15 cents, and then I put the word dollars under there, so when we add it together, it's going to have the dollars. And then the second part of this is, what is the old cost of an item that is now D dollars? Can anybody else not see me? Somebody said something that they couldn't see me. Somebody came on, but I couldn't hear you.
Can you hear me now?
I can hear you.
Okay, my computer kicked me out and I was trying
You're trying to do
it
what?
kicked me out and then
Uh-huh.
I went back in. Well, my computer kicked me out because I guess my internet connection failed. And when I connected back and called back, I'm on and I can hear everything you're saying, but I can't see anything. And then my mic wasn't working, but I just got the mic started working again, but the screen's still black.
Okay. I'm actually recording this, and so when I left a while ago, you'll actually have a big dead space because I forgot to stop presenting. So
Okay.
you'll actually see this. I'll upload it and send y'all the address where it's at. Is that okay? I'm actually
Yes,
on
ma'am, that's good.
page 382 in the book. So when you get onto your
Okay.
ebook, you can see page 382, and this is an example.
Okay, and then the ebook is on My Labs Plus, isn't it? Right?
Yes, ma'am. Yes.
Okay, thank you.
Uh-huh. So we know that the new cost, if something was cost C dollars and everything was going up by 15 cents, that this is our new expression we would use to find what the new cost is. If we have something that the old cost, what is the old cost of an item that is now D dollars, then D is going to be the new price, and we're subtracting the 15 cents. So now the expression to find the old cost is going to be D minus our 15 cents. So we have two different expressions here, one to find the new cost and one to find the old cost. Just given this one statement here, the cost of every item in the store is increased by 15 cents. We should be able to find the new cost and the old cost. Now I'm going to move over just a little bit. I'm going to skip a page or two here just because of time. In every unit, we're probably not going to have time to do every page or every example there is. If you have a certain example, or when you get on to do your homework, you will also notice, and I will try to put up a page for you to look at, that there is a button that says Ask My Instructor. So for those of you that have not used My Labs before, that question comes directly to my email. So it does not go to someone else within a company or whatever, or another instructor at Tri-County. It comes directly to me. Please hit that, and I can actually go on to my screen, work it out, and then send it right back to you. So that way it'll feel just like you're getting a one-on-one tutoring session. And that's the way I hope we can do this. And I can actually post it for everybody to see, just in case anybody's got questions about other homework questions. I will not post a name so nobody knows who it comes from. I don't want to embarrass anybody or whatever, but if you don't mind me sharing something, that's fine too. And always, if you have an easier way of doing something, please let me know. I don't want to make this the hardest thing anybody's ever done. So we always want to make sure we can kind of do it and do it correctly. We're going to look at, so something new here, a function. And a function, if we look at a Cartesian grid, and we know that the horizontal is our x-axis and the vertical is our y-axis, the function states for every x value there's only one y value. So that means that if I wanted you to plot the points -2, 2, -3, 2, -4, 2, 1, 2, 3, 4, and this is 2, -2, -4. So we've got -2, 2, -3, 2, -4, 2. Then everybody knows about the horizontal line test when you're doing a function. When I'm coming a vertical line test, when I'm coming across, I've only got one point showing as I'm coming across here. So that means that for every x value, I only have one y value. Now, if I were to add in another point of -2, -2, then this would actually stop this being a function. So a function is for every x value So for every x value, there's only one y value. And you may see this where it's talking about this in domain and range. So for every domain, there's only one range value that you have. So does anybody have any questions?
I don't.
Okay. We're at 11:21 right now. I'm actually going to stop here and go in and start the My Lab stuff and actually send you an email. So I don't know if I can do that. So I'm actually going to present my desktop here. Can y'all see my desktop? Not yet. Can y'all see my desktop now?
Yes.
Okay. I'm going into Firefox. And this is where you're going to type in tctc tctc dot mylabs with a s plus .com. Now, you will sometimes get this lock right here in the address bar. If you click on that lock, it says the connection is secure. You want to make sure that you're actually giving your site pop-ups. So you want to allow pop-ups on this site. If you don't, then you're not going to get a lot of the things that are going to go on. So I want to make sure that my pop-ups are showing. I've already actually, this is how I sign in all the time, so I don't have to go through. But when you get to this page, you're just going to put in your username without the @tctc.com. Click forgot password. For those of you who have not done this before, it'll say change password, and you go in and do that, and then it'll come back to this site. Now when I sign in, it'll take it a minute. Come on. And with Firefox, it will tell you when you go in and allow pop-ups and stuff, it'll tell you that your connection's not secure, but you have to go in this way. Now, I'm actually going to go in to show you a few things. This is what living in the middle of nowhere gets you. Come on, baby. Is this what y'all are getting?
Yes, that's what I'm getting.
Yes.
That's kind of funny that I'm the instructor and I'm getting that.
That's what I was talking about earlier. I get that on every little page I click.
Okay, well, whenever you go in, so for those of you, your assignments will be posted here under the assignment button now. As we can see, it's not showing up, so you can't get into that. You can go in your e-text here, or you can go in by chapter content. So if you just want to go in, our first unit's going to be on chapter 8. So you can just click there, go into chapter 8, and then you should be able to go in pretty good. The grade book here is where all of your grades will be listed. I do not put any grades in Blackboard. And your homework grades will be here too. Now, on the syllabus, it gives you a percentage of how much your homework is worth and how much each test is worth in your final exam. I will go into the grade book and put that. So every time you see your average, it should be a current average. That shouldn't be a problem. So if you have any trouble with that, just let me know. But yeah, I would like for you to try that. Like I said, I'll go in right now and see what the problem is and then get that situated. And when I come back, I'll send y'all an email because I can actually email y'all from here or from my Blackboard, and then send y'all and let y'all know that I've got something posted and hopefully that it's working. So if you go in after I email you and it's still not working, then please shoot me a text message or an email and let me know, and then I can see what's happening and I can call the company from there. So, any questions?
No.
Nope.
Okay. Well, I will see y'all on Friday if you can make it to class. And I will be posting these videos, as awful as they are. Just do not laugh at me. That's all I ask. And we will go from there. But thank you for joining me today, and we will see you on Friday.